We are working on section 6.4, and this is called solving radical equations. Okay, radical equations of y equals the square root of x. The graph of it looks like this. Now, if you end up with something that looks like this, where y equals the square root of a negative number, you're going to get an error when you type this into your calculator. The reason is because this negative number inside an even root is not a real number. In fact, it's called an imaginary number. And I'm not sure when you're going to get into this, but anytime you have a negative inside an even root, you're going to get y equals I. And then the 4, you have 2 times 2. It's going to pull out 2i, or equals y equals 2i is a better answer for that. But I'm not sure if you're going to use this in this section or not. I'm not seeing any indications of that. This might be something you run into later. So at this point, I want to explain to you how the steps that you take in order to solve rational equations. The first step is you want to isolate the radical to one side of the equation. Or the equal sign. Step 2, you're going to get rid of the radical by either squaring or cubing both sides of this equation. Step number 3 is you're going to solve. Then remember that after you solve, if your answer, or if you're working with a square root, you always want to check your answer, because square roots sometimes will give you answers that really don't work, and that's the reason. So let's go ahead and try this equation. We have 4 equals the square root of negative 2x minus 4. If you look at this, our first step is already done. The radical is by itself on one side of the equation. So we're going to go ahead and with step 2, which is this here is an even root. It's actually to the second power. So we're going to actually square both sides in order to get rid of that radical. So 4 times 4 is 16, and when you square that, it basically just gets rid of your absolute value sign, or not absolute value, your radical. Okay, so here's the first one. We squared both sides. Now, in this part, we want to solve for x. So since x is here, we want to isolate this term, get rid of this first. So we're going to add 4 to both sides, which gives us 20 equals negative 2x. Then we're going to divide by the negative 2 to get x by itself, which gives us x equals a negative 10. Now we want to check our answer, because we squared. So in the top we had 4 equals the square root of negative 2 times the negative 10 minus 4. So you can easily put this in your calculator to find out the answer, or you can just do the work. My calculator here, I don't know if you can see it. We're taking the square root of negative 2 times the negative 10 minus 4 equals, and that's a 4. So we get 4 equals 4, which is a correct answer. So that's a good answer. So our answer for that is x equals negative 10. Now, if you ever have an absolute value that is even, I don't know why I keep saying absolute values. If you ever have a radical that is even, the root is even, and it equals a negative number. Now remember, it has to be a number, not a variable. Then your answer is just going to be no solution. Because when you take it absolute value, remember how we had 2 times 2 equals 4, and negative 2 times a negative 2 is 4. It's always positive. So you will never have a negative number. So an equation that you might encounter is negative 4 equals absolute value of u plus 4. Again, we have a number that's negative out here, and then just the radical on this side. So that in itself is no solution. Okay? Let's work a problem now. We have negative 4 minus y, that's cubed root, equals negative 3. When you look at this, remember what I said back here? If we have an even root and a negative number, there's no solution. If it's an odd root, which we're working with, we can have a negative solution. So the only thing you have to be careful with is the even roots. So to get rid of this root, we have to do the opposite function. The opposite of a root is an exponent, so we're going to raise it to the power of 3. This one is going to be negative 4 minus y equals, and negative 3 times negative 3 times negative 3 is negative 27. So now we're going to solve. We're going to add 4 to both sides. We're going to get negative y equals negative 23. And we want to divide by negative 1 to make y positive, so y is 23. And that is our answer. We don't have to check odd roots, but we do have to check even roots. Let's work this one now. We have the square root of 3x plus 10 equals x plus 2 squared. Actually, I'm looking at somebody else's paper. That is the problem that we're looking at. We're looking at the square root of 3x plus 10 equals x plus 2. So, first step was to get our absolute value. Again, the radical by itself. We have the radical by itself, so step 1's done. Step 2 is to get rid of that radical. This is an even index or root, so we're going to take everything. We're going to take that side by 2, and we're going to take this side by 2. So when we write this out, we have, I don't know if you can see that one very well. We have 3x plus 10 equals, and this is where we're going to have to FOIL this out because we have 2 of these. We have to, so we want to solve. So this side is going to stay the same, and we're going to do first times first, it's x squared, outer times outer, that's 2x plus inner times inner is 2x. And then out last times last, 2 times 2 is 4. Combine our like terms to get x squared plus 4x plus 4. Now we're going to get everything on one side. If you notice, we have an x squared on this side but not on this side, so we're going to move everything to this side and make this side 0. So we're going to subtract 3x, and notice I'm putting them in line with its like terms, and we're going to subtract 10. So we're going to get 0 equals x squared plus x minus 6. Now we want to solve this, and the only way to solve it is to factor. Factors of 6 that subtract to give us 1 is 2 and 3. We know the signs are going to be different. The biggest one's going to be positive. So the 3, since this is bigger, is going to get the positive here, and this is going to get the negative. So our answers for this one, we're going to get x equals a negative 3 or 2. Now remember, we squared our things. So anytime you have an even root and you square it, or you have to check your answers. So let's stick this back in. We have 3x plus 10 equals x plus 2. And that's in the square root. So we're going to try the negative 3. So 3 times negative 3 plus 10 equals a negative 3 plus 2. 3 times, that's negative 9 plus 10. That is 1. Square root of 1 is 1. But over here, we've got a negative 1. 1 equals a negative 1. That doesn't work, so we have to throw that answer out. And you didn't see all that. So it's 1 equals negative 1. We have to throw this answer out, the negative 3. Now we're going to check the 2. Usually one of the two work, but always check it just to make sure. 2 plus 2. So we've got 6 plus 10 is 16. The square root of 16 is 4. And 2 plus 2 is 4. So that one does work. So our answer on this one is x equals 2. Or actually, just 2. Now we have the square root of 29 minus 7x equals x plus 5. All right. We have step 1's done. The radical is all by itself and it equals over here. Now we have a variable over here as well, so we have to be careful. We can't just automatically decide, well, it's positive or negative. We have to work it out. So we want to square our sides to get rid of the radical. So since the index is 2, we're going to square it. And that leaves us with 29 minus 7x equals, and we have x plus 5 times x plus 5. We're going to FOIL that. We're going to leave this side the same. X times x squared, we've got 5, and another 5 is 10x. And then 5 times 5 is 25. We have x squared here, but not over here, so we're going to move. We want our x squared to be positive, so we're going to move all this stuff over here. Subtract 29 and add 7x, which gives us 0 equals x squared plus 17x minus 4. If I did that right. I did not do that right. I knew that was weird. My original problem was 29 plus x. So I want to subtract my x. I did it right on my thing. It's just, it's not going to work out because I wrote the wrong problem down. So be careful when you're writing down your questions that you transfer it right. You don't make a goof like I just did. So we have x squared, and this is going to be plus 3x minus 4. So that's going to be a whole lot easier to factor than what I come up with earlier. So to factor this, we've got x's, we factored the x's, factors of 4 that subtract to give me 3, or 4 and 1. They're different, the biggest one is positive. So my answers are going to be negative 4 and 1. Now, we need, since we squared them, we have to check our answers. So we're going to go back up here, 29 plus 7, negative 4. We're going to take the square root of that, negative 4 plus 5. So this side is going to be 1. Let's see if we get a 1 on this side. We've got 29 minus 28, which is the square root of 1. So we indeed get 1 equals 1. So this one is going to work. What about the 1? We got 29 plus 7 times 1. Square root of that equals 1 plus 5. So we have 6 on that side. So if we have 29 plus 7 on that side, we get 36, I believe. And the square root of 36 is 6. So 6. This one, both of them happen to be good answers. So we can use both of them. So that's why we always check, because sometimes we get one that doesn't work, sometimes we don't. Always check your works on when you square or when you have even things. Okay. Now, let's try this one. We've got negative 2 minus t, and this is in the square root, equals a negative 4. Alright, so we're going to follow our steps. We have this is by itself on one side. So step 1's done. And we always check. We've got an even root, but we have a negative over here. Uh-oh, that's a problem. When we have even roots, all our answers are always going to be positive. So we have, this one is no solution. Now let's do square root of 2 plus 3w equals the square root of 5w minus 4. Well, we actually have radicals on both sides of the equation, but this is good because they're both kind of isolated. So that first step is already done. We have a radical on this side and a radical on that side. So, and they're both, the index is 2, so to get rid of them, we're going to square both sides. So that effectively gets rid of our radicals, which leaves us with this equation. So now we want to solve. Okay, well, this got the bigger, so let's take 3w, and then we're going to add the 4 so that we get our numbers on one side and our variables on the other. So we have 6 equals 2w. Now we're going to divide by 2. W is 3. We squared, so what do we have to do? We have to check our work. Gotta check. So we have 2 plus 3 times 3, and then we have 5 times 3 minus 4. So this is 2 plus 9, which is 11. And then we have 15 minus 4, which is 11. And guess what? They equal each other, so 3 is a good answer. And they work. Now we have plus 7y, and we're going to take the cube root of that, equals a negative 7. Now, step 1 is done. The radical is isolated on one side of the equation. We do have a negative here, but our index is an odd index, so we can't have a negative there. It's okay. So what we want to do now is we're going to cube both sides. So, if we cube both sides, what do we get? We get 3 plus 7y equals, and a negative 7 times a negative 7 times a negative 7 is, do the math real quick, a negative 343. So now we want to solve to find out what our y is. If we subtract the 3, we're going to get 7y equals negative 346. We're going to divide by 7 to get our y's by itself, and a negative 347. 346 divided by 7 is not, it won't reduce. So our answer is that there is no need to check because it is an odd root. We only check the even roots. All right. Let's try this one. We have u plus 4 equals the square root of 3u plus 22. All right. This is isolated on one side of the equation, so step 1's done. It's an even root, but we don't know if this is positive or negative, so we're going to have to solve in order to find out. So what we're going to do is we're going to square each side so that we can get rid of that radical. So when you square it, remember we're going to FOIL this, so we're going to have u plus 4. So we've got u squared, then there's 4, 8u plus 16, and then that gets rid of the radical sign. We have u squared on one side but not the other, and it's positive over here, so we're going to bring everything over to this side. We're going to subtract the 3u and subtract the 22, and it gives us u squared, what is that, 5? Yep. Plus 5u minus 6, yeah, equals 0. Now to find our solution, we have to factor this. U times u is u squared. Factors the 6, the subtract to give us 5. Well, those are 6 and 1. They're different. The biggest one is positive. So my u can be negative 6 or 1. But we squared. So what do we have to do? We have to check. So we have negative 6 plus 4 equals square root of 3, negative 6 plus 22. This is negative 2 equals, now if you notice, remember before we had no solution when there's negative, so we have a radical with an answer of negative 2. This is probably not going to work. So we've got negative 18 plus 22, 18, 19, 20, 22, which is the square root of 4, and the square root of 4 is 2. So that's right. That one does not work. So we have to throw the negative 6 out. And more than likely the 1 will work, but let's check it just to be on the safe side. Got 3 times 1 plus 22. This is 5. And 3 plus 22 is square root of 25, which is 5, equals 5. That one works. So the answer for that one is just the 1. It shows that I did that. Oh, no, that's right. Yes. Didn't want to give you the wrong answer if I did it wrong, which happens from time to time. Okay, we've got a couple more to go through on this section, and then we'll get to start the new one. This problem is 5 equals the square root of negative 4u minus 4 plus 1. Okay, our instructions are for solving these, saying the first thing we had to do was isolate this radical. And there's a 1 out here that's adding on. So we need to get rid of that one first. We need to subtract 1 on both sides. So this gives us 4 equals negative 4u minus 4. Now that the radical is by itself, we can undo it. And the way we undo that is by squaring both sides. So we have that squared and that squared. 4 times 4 is 16 equals, and that square gets rid of the square root. So negative 4u minus 4. So now we're in the process of solving. So here's the term with the u in it, so we want to add the 4 to get rid of, to get it by itself. So we've got 20 equals negative 4u, and then we have to divide by 4, negative 4, to get u by itself. So we get negative 5 equals u. Now, do we have to check this? Yes, we do, because we squared the sides. So let's go back to the top, our original equation. We had 5 equals negative 4 times a negative 5 minus 4 plus 1. So we have this negative 4 is 20 minus 4 is 16. Square root of 16 is 4 plus 1 is indeed 5. So it works. That is our answer. Negative 5 is our answer. Our last one, 4 equals square root of 8 minus 4u plus 4. Again, our steps are to isolate this. Since it's not by itself, we need to make it by itself. So we need to subtract 4 from both sides. And that gives us 0 equals the square root of 8 minus 4u. Now we have to undo this radical by squaring both sides. So once you square this side, you square that side. 0 times 0 is 0. So we get 8 minus 4u. Now we want to solve. Well, this one we could actually add the 4u, so we make it positive. Makes it 4u equals 8. Divide by 4 gives us u equals 2. But do we have to check this? We squared it, so yes we do. So our check is going to be 4 equals 8 minus 4 times 2 plus 4. So we have 8 minus 8 is 0. Square root is 0, 0 plus 4. And yep, it checks out. So 2 is our answer, because 4 does equal 4. Just remember your steps. If you need to write the steps that we had from the very beginning out while you're doing your work, it might help you. Here's the steps. Write those steps out on a little sheet of index card or a little sheet of paper, and that way you can have them on site. The sooner you can memorize these steps, the easier it gets.